Hello again. I thought it'd be interesting to find out a bit more about these Omniwheel buggies that you start to see in toy shops these days. Omniwheels are quite interesting. Omniwheels are like ordinary wheels, but they have these rollers on the side, so that as well as going as a conventional wheel does, they can also slide sideways. The wheels are arranged at the corners, as you can see, and depending on what direction you want it to go in, you either move all the wheels in the same direction or in opposite directions, or any combination you can imagine of speed and direction to make the buggy go in any direction. You've got 3 degrees of freedom: forwards, backwards, left, right, and rotation. What makes this project interesting to me is that it's quite complex and quite counterintuitive to work out which wheel has to go how fast in which direction to make the buggy go forwards, backwards, left, right, diagonally, or rotate, steering like a car. And to get that information to the 4 motors, when what you're starting with is the output from a transmitter like this, forwards, backwards, left, right, and steering, you've got 3 degrees of freedom to control, and the processing required to get each motor working in the right direction and right speed is quite considerable and quite complex. I first started this project a couple of years ago, but I found the programming really difficult, and I put it on the shelf for a while, and I've recently gone back to it and cracked the problem. What I've got here is the receiver that receives the signal from the transmitter, and that feeds into 2 microprocessors. They're identical 20M2 pickaxe microprocessors. This processor controls these 2 wheels through this motor controller, and this processor controls these 2 wheels through this processor. By having a bit of parallel processing, halving the work between the 2 processors, I was able to get the processing fast enough to actually respond promptly. Otherwise there was a huge delay between operating the transmitter and the response of the car. The other issue is that I had to overclock both these processors by 8 times to get them working fast enough. The algorithm that decides which wheel has to go in which direction and how fast is actually quite complicated. It took me a while to work it out, but I have finally cracked it, and I'm very pleased with the result. Because it goes sideways, I thought it best to put a cover on it that looked like a crab, and this is a horseshe crab. The only slight irony is that I've since realised, of course, a horseshe crab isn't a crab, it's an arachnid. And anyway, horseshe crabs don't go sideways. Never mind, it looks quite cool.